welcome to episode 6 of the AWS Weekly Recap. I am your host, Keidrick Pettaway. Let's jump right in. Topic number 1 under general and recent announcements. AWS Systems Manager run command now supports interpolating parameters into environment variables. So this was just newly released in Schema version 2.2, and basically what this tells us is that by interpolating parameters into environment variables, SSM documents can now safely handle parameters by converting them into environment variables before execution. This approach significantly reduces the risk of command injection by allowing parameters to be treated as data and not code. So basically what this is saying is these values will get picked up at runtime, and basically it's popping out the parameter name for the parameter value during the interpolation. So should help with security, and this is just me reading over this. I actually haven't executed this myself, but this seems to be a good safeguard for locking your system down and being able to efficiently in the ability to repeat your deployments by having those variables pulled out now. So we'll see how it goes, but good news out of AWS. Next up is in the basically this is under developer tools. So with everything AI going on now, AI, LLMs, big data, foundational models, AI is the big if you want to say buzzword or keyword of the hour right now. So everybody's kind of buying into AI, which I don't think is a bad thing, but there's actually a lot that's untested with AI and a lot more unproven, even though it's growing and iterating very swiftly. There's just still a lot of unknowns out there. So with that being said, the good people at AWS and the serverless compute department, they've put out basically 6 AI architectural patterns that will be good for you to learn and or deploy as you build out your AI infrastructure. And I'm just going to read through them really quick here. So the first part, this 2-part series explores the different architectural patterns, best practices, code implementation, and design considerations essential for successfully integrating generative AI solutions into both new and existing applications. So that's kind of the framework behind it, or the thought behind the framework. And then, like I said, they go on to give you several patterns. So the first pattern is the synchronous request response pattern. Second is asynchronous request response. Third pattern, async streaming response. Fourth pattern, buffered async request response. Fifth pattern, multimodal parallel fan out. And then the sixth pattern is the non-interactive batch processing. These posts provide 6 architectural patterns on building Gen AI applications using AWS serverless services. And then kind of in these series of posts, so it's a total of 2 posts, it kind of breaks down the use case and the justification for using each of these patterns. So this is not going to be like a one size fits all. It's kind of like, hey, here is a general guideline for what the best practices are, and then based off your particular workload or use case for your data, you kind of adopt the patterns that make the most sense and fit your use case. So, like I said, this is kind of like a outline of, hey, if you're wanting to do this, maybe you want to look into this pattern. So this particular one here, I believe the first two talk about synchronous versus asynchronous, and of course we know synchronous is going to be the caller is never waiting for the response to come back in a synchronous pattern. So in this pattern, responses are generated and immediately delivered, while the client blocks waiting for a response. So this is a caveat to using the synchronous request response. Basically, you're blocked until you get that full response back. Whereas with, and then it also goes on to say, simple to implement, has predictable flow, and offers strong consistency. It suffers from blocking operations, high latency, and potential timeouts. So if depending on your application workflow, sometimes you may not get immediate response. So you may need to use a event of some source to say, hey, all right, I want to put a message on this queue or on this topic, and then have the UI thread go ahead and do something else, but it's not waiting for the response to come back, because it's pretty much like a, hey, I've made it to the point where my only job was to send the request and get a response back, and then we may display something in the UI. This is just one example, but like I said, this particular pattern is going to be blocking on that. So you would need something on the other end, the receiving end, to say, okay, yes, I acknowledge your request. Your response back downstream is a 200, and then you can get the UI or whatever middleware piece you have in between the client and the servers to no longer be blocked with this particular pattern, or by using one of these particular patterns. Whereas the next one mentioned here in the diagram is a what we call asynchronous request response. This pattern provides a full duplex bi-directional communication channel between the client and server without clients having to wait for updates. And the biggest advantage is it is non-block in nature that can handle long-running operations. So, like I said, that first scenario that I kind of mentioned was a mixture of the synchronous response, and on top of that, we're just going ahead and sending that response and just getting the immediate. We're sending that request and then getting the immediate response back. But in this particular pattern, it's just saying, hey, we expect this request to take a long time, or it may not be as instantaneous as you like, but also at the same time, it's not going to be a blocking call between the client and the server. So basically, the client can go ahead and do whatever the next sequence of events is that it needs to do in this operation, and then whenever that response finally comes back, it can say, hey, I got your response back, now what do you want to do with it? So, but basically, like I said, you have 6 different patterns that they review here in this 2-part post. So next is async streaming, and I'll leave the link down in the description of the video, or if you listen on podcasts, the link will be in the show notes. So, but this is a 2-series post that kind of gives you some best practices for building out your Gen AI or leveraging Gen AI. Next topic that we have is out of training and certification. Um, so AWS is continuing to build out their training and certification, and just recently they've added additional courses to AWS Skill Builder, as well as they have started offering Skill Builder subscription services. So you can kind of think of this as like if you've used any of the other cloud, most of them are cloud agnostic training sites, with like a cloud, Guru, Exam Pro. There's a ton of them out there, but basically you can pay a one-time fee, yearly fee, per month fee, and you basically unlock whatever you want to as part of that subscription. So, let's say your subscription is, let's take a look, individual annual subscription. Let's see how much this is here. Individual subscription. Let's see here. It's going to give us a price. Not sure the price yet. But anyway, this would be like any of the other cloud learning platforms out there. You pay a monthly rate, and then based off of that, you kind of view all of the videos that you want within that month. So now, said all that to say that Skill Builder does still offer free training. Most of it is on the, I would say, beginner to intermediate level. So you may have some foundational training on there, like intro to cloud services, and then it may go into another course may go into like S3 basics, or what is S3, stuff like that. But then around the 100 to 200 level, it kind of starts to shut down as far as the amount of content, and then that's when the subscription comes into play. So if you wanted to do a deep dive into S3, which is an example, you may need that subscription level, no longer having the free account, but you have a paid subscription, and then you can do a deep dive into S3, and it could be how you access S3 from the CLI, from the console, from API, whatever language specific API you may be interested in. But those are kind of the distinctions between the regular Skill Builder and the Skill Builder accounts with a paid subscription. So basically, you're paying for more in-depth information. And finally, wrong one. Finally, for this week is that, and this actually just came out, AWS named as a leader in 2025 Gartner Magic Quadrant for cloud native application platforms and container management. So Gartner is a big deal in the tech industry, and they kind of rate a lot of these cloud providers, security groups, things of that nature. But so this is, I would say this is a pretty good milestone for AWS. So AWS has been named a leader in the Gartner Magic Quadrant for cloud native application platforms for 2 consecutive years. AWS was positioned highest on ability to execute. Gartner defines cloud native application platforms as those that provide managed application runtime environments for applications and integrated capabilities. So basically, at least I'm gonna say from my understanding of this is saying AWS is one of the best cloud service providers to be able to get up and running in a relatively timely manner, and to get your workloads executing in a production environment as well. So I know people give AWS a lot of crap, but kind of with my experience with it, it seems like there's really what the services offer is multiple ways to accomplish the same task, depending on what your specific need for the task is. So if you kind of if you may not know your workloads, or you just kind of want to start something off with a proof of concept, AWS Lambda could be very ideal for that. You can get it up relatively quick, and it's kind of pay as you go, and then